Okay, in this problem, you are going to try to figure out, given a certain amount of building materials, you're going to try to figure out the maximum area you can get out of those building materials. So how can you cut 20 feet of dividers in such a way that it gives you the biggest space possible? This problem says that you are going to be sectioning off a corner of a room for a storage area, like a little closet area. And since it is jammed in the corner of a room, you only need 2 walls. So out of the 20 feet of dividers that I'm given, I actually only need to make 2 walls to get my little closet space. So should I cut the first wall 5 feet and then the other wall would be 15? Or should I make the first wall 12 feet and then the other wall would be 8? So I'm not really sure how to get the maximum amount of area for my space. Sorry. Alright, so the first thing that I'm going to do is, since I don't know how much to cut off for my first wall, I'm just going to make it some unknown amount x. And then the other wall is going to be represented by the amount you started with minus the amount you used for your first wall. So this side's some unknown amount x, and the other side's going to be represented with 20 minus that x amount. And then since we're trying to figure out how to get the biggest area here, we're going to use the area formula for a rectangle. An area is equal to length times width. And the A part of the problem is asking us to write this function style. So our area of x is equal to, our length is going to be x, and our width is going to be 20 minus x, the other side. It doesn't matter really which side you call length and width. I'll make the x the length, and then the width has to be the other side. Okay, so that's our formula, and that's what we're going to be putting into our graphing calculator. And before I do that, let's go ahead and just find the domain, which would be B. The domain is just what x values that you can pick for the problem, like what x amount can you cut off. Well, you can't cut off less than like 0 amount. You can't cut off a negative amount. So your domain is going to start on the low end at 0. So you have to cut off at least something. So it's going to be 0, 2, and the biggest amount of x I can cut off is 20 because I don't have more than 20 foot of dividers. I can't cut off 30 feet for my first cut if I don't have 30 feet to start with. So the biggest amount can be up to but not including 20. Like you can't cut 20 feet for the first side, or there would be nothing left over for the second. So in between 0 and 20 is the amount that I can cut off for that first side. That's what the domain is, figuring out how much you can cut off for your first side, what your x can be. And then the C is graphing the function with the graphing calculator. So we're going to go ahead and put that in. You could do this 2 ways. You can just punch this into your calculator, or you can actually distribute first, which will give me 20x minus x squared. Either one of those is fine. It's totally up to you. So into y equals, I'm going to punch in 20x minus x squared. And then hit graph. And I can't see my graph. It looks like it didn't work, but that's just because my graph window is only going from -10 to 10 on both the x and y axis, which means that I'm going to have to zoom in or out. Now you can keep using your zoom feature if you want to, by going into this window and just playing around with it, but in this case I think it's best if we change our grid by hand and change each dimension by hand. I know that I can't pick an X value that is less than 0 because I have to cut like something positive off for my first side, so I'm just going to make that 0. And then I know the biggest amount that I can cut off my 20 feet of foot dividers is like 20. So my X window only needs to go between 0 and 20. And then my Y min, the biggest area, or I should say the smallest area that I could have, the smallest area has got to be bigger than 0, but not less than that. So I'm going to put my Y value at 0. And then my Y max, I really don't know how far to go with it. So usually I'll start like maybe with 100, and if I still can't see the highest point of my graph or lowest point, then I'll like change it, make it more or less. So I think we'll start with I don't know, 100. And then I'll look at the graph and see how that's working. Oh, that's like exactly like perfect there up top. So maybe I'll make it just a little bit more. I'll make my Y height maybe 150. Now let's do 125. Change my mind. And then hit graph. And that looks like a very, very nice window that captures everything I need. I can nicely see my maximum value. Now the max, this x-axis here is your initial cut. That's the length that you're cutting off. So here's a cut of 1 foot. That leaves 19 for the other side. And then the corresponding Y value that you get on the graph, that's actually the amount of area you have. So it looks like when I cut off 1 foot, I don't get a very good area. The Y value of this graph is not the width, the other dimension. The Y value on this graph is the actually area you get when you cut off a certain amount of X. So if I cut off 1, 2, 3 feet here, and I look at my area, which is the Y value, that doesn't seem to give me the maximum area. So instead of trying to like keep going over and counting the X's and figuring out what X gives me the highest area, I'm just going to use my max feature in my calculator. So I'm going to hit second trace, which gives me my calculate window, and I'm going to hit max. And then I'm going to let my calculator figure out that ordered pair for me. I'm going to let it figure out what X value gives me that highest area that I get up at that point. So we have to do our left bound, which means move a little bit to the left of your high point, hit enter. Then it wants a right bound, so I'm going to move a little bit to the right. And then it wants me to guess exactly. So I'm going to move as close to right on top of that maximum point and hit enter. And then here is my maximum. It's at 10, 100. 10 is the X amount that you should cut off in order to get the biggest area. This Y value of 100 is not the other side. You are not going to have a wall of 10 by 100. That 100 is actually representing the area, the maximum area. So 10 is the first cut. This 100 that you're getting for the Y is the maximum area you get. You need to take this 10 that you cut off and plug it back into the other wall. So I'm going to come back over here, and then this is my maximum, this is my initial cut of 10. The other side is going to be found by taking 20 minus 10. The 100 is not the other side wall. It's the area, the maximum area you get. So 20 minus 10 is also 10, so it looks like your length and your width are both the same. Okay, so we already graphed that with C. That's done in the graphing calculator. And then D would be finding those dimensions. So your length is equal to x, which is just 10. The width is equal to 20 minus x, which is 20 minus 10, or 10. And the area that you get at an x of 10 is equal to 100. And I probably should have just plugged that in first to the area formula. So let's do a do-over here. Equals 10 times 20 minus 10. I'm getting that from right there. And that's 10 times 10, which is 100. Okay, so when you do your calculator and you plug your formula or your function into your calculator, you are not given instantly both dimensions. You're given one dimension of your wall. You need to plug that number back into the expression that you're using for the other wall, and what you're actually getting in your calculator, which would be 10, 100, is your initial cut and the area that you get with that cut.